Dear friends, welcome to EPG Pathshala. I am Dr. Nitesh Goyal from DAV College, Chandigarh. I am going to present before you the 24th module titled Measures of Central Tendency and Variation under the paper Tourism and Hospitality Research. Dear friends, after the completion of this module, you shall be able to elaborate the various types and the uses of measures of central tendency. Secondly, you will be able to understand the various measures of dispersion. Thirdly, you will be able to understand the measures of asymmetry. Before beginning, I would like to give you a brief introduction about the topic. The common quantities which are used to outline the data set is the center or the mean value. The center is defined as a single value, should be chosen in such a manner that it gives a reasonable and fair view about the normality of the data values. There are many ways in which the data values can be statistically approximated. One of the most useful techniques of central tendency is the mean. However, using only the mean to approximate the normality can lead to fallacious conclusions. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such, measures of central tendency are also at times identified as the measures of central location. They are also referred to as the summary statistics. The mean, commonly known as the average, is most likely the measure of central tendency. The mean, median, and mode are all valid measures of central tendency, but under different conditions. Some measures of central tendency become more appropriate to use than others. In the upcoming sections, we will look at the mean, median, and mode, and then learn how to calculate them and under what conditions, and also highlighting the superiority of mean over the other methods of the central value and vice versa. The various measures of central tendency highlight the items which have the capacity of being together. Such kinds of measures of statistical averages helps the researcher in arriving at one of the most representative figures from the entire set of values. It is also known as the statistical average. The measures of central tendency includes in its ambit the components such as mean, median, and the mode being the most popular averages that are studied. There is no doubt the arithmetic mean is the most commonly used measure yet. Mode and median are more suitable measures under certain set of conditions only and for different types of data. However, the various measures of central tendency should adhere to the following points, and these are: firstly, it should be capable of being calculated and understood too. Secondly, it should be defined rigidly. It should have only one interpretation so that the personal prejudice or bias of the investigator does not affect its usefulness. Thirdly, it should be representative of the data. If it is calculated from a sample, then the sample should be random enough to be accurately representing the population. Fourth, it should have the capability of being collected in samples, that is, not be affected much by the sampling fluctuations. Fifth, it should not be much affected by extreme values. If few very small or very large items are presented in the data series, they will unduly influence the value of average by shifting it to one side or the other, so that the average would not be really typical of the entire series. Hence, the average chosen should be such that it is not unduly affected by such extreme values. So, let us take them one by one. Firstly, the mean. The most commonly used measure is the mean or the arithmetic mean, even though average in general means any measure of central location. When you use the word average in your daily routine, you always mean the arithmetic average. The term is widely used by almost everyone in daily communication. You speak of an individual being an average student or of average intelligence. You always talk about average family size or average family income, or say grade point average, or in short, which is commonly known as GPA for the students, and so on. Mean, also known as arithmetic average, defined as the value obtained by dividing the sum of all the values by the number of the items. It can be illustrated below as per the formula on your screen. Pause. Now it says summation xi upon n, where x bar is the symbol used for mean, and the summation represents the sum of all the data values. Xi is the value of the any single value of the data set, and n represents the number of items. Under the frequency distribution, mean is calculated by using the formula again as shown on your screen. It is summation of fi xi upon the summation of fi, where summation of fi xi is calculated as f1 x1 plus f2 x2 till fn xn, which is divided by summation of fi. Fi stands for f1 plus f2 till fn. At times, if one does not want to calculate the arithmetic mean, we can also compute the value of weighted mean in order to obtain a realistic average. Again, the formula is presented on your screen. Pause. It is, as you can see on the screen, the formula here, x bar with the w in superscript is the weighted mean. Wi represents the weight of any item of x, and xi represents the value of any item of x. Now, there is also a shortcut method for calculating the mean. If we use assumed mean average A under the shortcut method, then the mean value can be computed as per the formula shown here. Pause. Here it is calculated as A plus summation of xi minus A upon n, where x bar represents the symbol used for mean, summation is representing the symbol of summation or the sum total of the values. A denotes the assumed mean, xi denotes the value of the ith item, and n refers to the number of total items. Let's take on the advantages of arithmetic mean. First, its concept is familiar to most of the people and is intuitively clear. Second, in it, every data set has a mean, which is unique and describes the entire data to some degree. For example, when you say that the average salary of a professor is 25,000 per month, it gives you a reasonable idea about the salaries of all the professors. Third, it is a measure that can be easily calculated. Fourth, it includes all the values of the data set in its calculation. Its value varies very little from sample to sample taken from the same population. Sixth, it is useful for performing statistical procedures such as computing and comparing the means of several data sets. Having been stated the advantages, it also suffers from certain disadvantages. These are, firstly, the value gets affected by the extremes and hence is not much reliable when the data set has extreme values, especially on one side of the ordered data. Thus, a mean of such data is not truly a representative of the data. For example, the average age of 3 persons of ages 4, 6 and 80 years gives you an average of 30 years, which is nowhere closer to any of the figures of the complete data set. The second disadvantage, it is tedious to compute for a large data set as every point in the data set is to be used in the computations. Third, it does not allow computing the mean for a data set comprising of open-ended classes. Fourth, it cannot be calculated for qualitative characteristics such as beauty or intelligence unless these can be converted into quantitative figures such as intelligence into IQ. Second measure of central tendency, the median. Now, the second measure of central tendency that has a wide usage in data analysis is known as the median. It is defined as that value of a variable which segregates the data series in such a manner that the number of items below and above the central value is equal. In other words, half of the total number of observations lies below the median and half above it. The median is thus a positional average. The median of ungrouped data is found easily if the items are first arranged in order. The median may then be located simply by counting, and its value can be obtained by reading the value of the middle observation. For example, if you have 5 observations whose values are 8, 10, 1, 3 and 5, the values are first arranged in an order like 1, 3, 5, 8 and 10. This is an increasing order. It is now apparent that the value of the median is 5 since the 2 observations are below that value and 2 observations are above it. But when the number of observations are even, there is a difficulty in locating the mid value. So, the median is taken to be the average of the values of the items lying on the either side of n plus 1 upon 2, where n represents the number of items. Thus, if values of 6 items of a series are 1, 2, 3, 5, 8 and 10, the median is the value of item number 6 plus 1 upon 2, that is 3.5, which is approximated as the average of the third and the fourth item, that is 3 plus 5 upon 2 is equal to 4. First, arrange the data as an array of increasing magnitude. Second, obtain the value of n plus 1 upon 2th item. Thus, the median is defined as a positional average. For example, while estimating intelligence, etc. Moreover, unlike mean, median is not affected by extreme values. The third measure is the mode. Mode is defined as the most repeated value in a series. Mode in a distribution refers to that value in a series around which there is a maximum concentration. Generally, mode is the size of the item having the maximum frequency, but at times such an item may not be mode, maybe due to the effect of frequencies of the other relative items in a series. Just like the median, mode is also a kind of positional average which is not affected by the values of extremes. Thus, mode proves its utility where one wants to eliminate the effect of extreme variations. For instance, a manufacturer of shirts, would be interested in finding out as to which size is much more in demand so that he can manufacture a larger quantity of that size in demand instead of producing the same quantity for all the sizes. In such a case, the manufacturer wants an idea about the model size. However, mode is also not spared by certain limitations. The decision of selecting one average over other will depend upon the nature, the type of the research study and the objectives of the research study, as a particular value cannot be taken as suitable for all types of studies. Let's take on the measures of dispersion. The average or the mean represents a particular value as best as a single figure, but it fails to give any idea about the spread of the items of a variable in the set. In order to arrive at the suitable answers, statistical techniques called measures of dispersion are applied. Some important techniques of dispersion are the range, the mean deviation and the standard deviation. Out of these three, range is the most common and simple measure of dispersion. It is calculated by taking the difference between the highest and the lowest values in a series. Thus, the formula is the range is equal to highest minus the lowest values. One of the most common and the simplest technique of dispersion is the range of distribution. It is defined as the difference between the highest and the lowest values in the series. For example, if the marks received in an examination taken by 248 students of a particular class are arranged in ascending order, then the range will be equal to the difference between the highest and the lowest marks. One of the major drawbacks of range as a measure used in statistics is that it is affected by fluctuations in values. As such, range is mostly used as a rough measure of variability and is not considered as an appropriate measure in serious research studies. The second measure of dispersion is the mean deviation. Mean deviation is the difference between the averages of the values of the items from the average of the complete series. Such difference is known as the deviation. While calculating this, the minus sign is ignored. Mean deviation is thus obtained as per this formula. Pause. Now, as you can see the formula on your screen, here the values of x, x bar and m are given. Here the values are calculated based on the deviations calculated from mean in the first formula, deviations obtained from the median in the second formula and deviations obtained from the mode in the third formula, where xi is the ith value of the variable x, n refers to the number of items, x denotes the arithmetic average, m denotes the median and z denotes the mode. Mean deviation is an absolute measure of dispersion. Thus, coefficient of mean deviation is calculated by dividing the mean deviation by the mean value calculated as per the respective series. Mean deviation and its coefficients are used in statistical studies for judging the variability and also helps in arriving at right conclusions. The third measure of dispersion is the standard deviation. It is one of the most widely used measure of dispersion of a series and is considered as an accurate measure of dispersion or say variability. It is defined as the square root of the squares of the means which have been calculated as per the respective series. Standard deviation in case of individual observation can be calculated by using the formula as follows. Now, the standard deviation, like mean deviation, is also an absolute measure of dispersion. Thus, a relative measure is also needed here also to obtain a better view. Standard deviation is a measure of dispersion of a set of data from its mean. It is calculated as the square root of variance by determining the variation between each data point which is relative to the mean value. If the data points are further from the mean, there is higher deviation within the data set. Now we come to the last part, the asymmetry. Now the first asymmetry measure is the skewness. Skewness is a measure of asymmetry. More precisely known, it refers to the lack of symmetry. A distribution or data set is symmetric if it looks the same towards both the left and the right from the center point. The types of skewness. If the teacher expects most of the students get good marks, if it happens, then the curve looks like the normal curve as shown on the screen. But for some reasons, for example, lazy students, not understanding the lectures, not attentive, etc., it is not happening. So we get another two different types of curves, or the two other curves also represents the male and the females. The measure of skewness. Carl-Person coefficient of skewness is formulated as Sk is equal to thrice of mean minus median divided by the standard deviation. Now, how do we interpret the value of measure of skewness? If Sk, that is the skewness, is 0, it is inferred as the frequency distribution is normal and symmetrical. If Sk more than 0, the frequency distribution is positively skewed. If Sk less than 0, it is negatively skewed. Now, when the distribution of item in a series happen to be perfectly symmetrical, it results in following type of curve for the distribution as illustrated in the screen. The curve shows no skewness, in which case we have mean is equal to median is equal to mode. The second measure of asymmetry, the kurtosis. The distribution of data and probability distributions are not of the same shape of all. Some are asymmetric and skewed to the left or to the right. Another feature of the distribution is the shape of the tails of the distribution on the far left and the far right. Kurtosis is the measure of the thickness or heaviness of the tails of a distribution. The kurtosis of distributions is in one of the three categories of classification. First, the Mesokurtic, second, Leptokurtic, third, Platykurtic. Let's take them one by one. Mesokurtic. Kurtosis is commonly measured with respect to the normal distribution. It is a kind of distribution that has tails that are shaped, which can be roughly illustrated as the same way as any other normal distribution. Not just the standard normal distribution is said to be mesokurtic. The kurtosis of a mesokurtic distribution is neither high nor low. Besides the normal distribution, binomial distributions for which p is close to 1 by 2 are considered to be mesokurtic. The second type, Leptokurtic. A Leptokurtic distribution is one that has kurtosis greater than a mesokurtic distribution. The Leptokurtic distributions are sometimes identified by peaks that are thin and tall. The tails of these distributions lean towards both the right and the left, are thick and heavy. The Leptokurtic distributions are named by the prefix lepto, meaning skinny. One of the most well-known Leptokurtic distribution is student's T distribution. The third and the last type is the Platykurtic. The third classification for the kurtices is the Platykurtic. These distributions are those that have slender tails. Many a times they possess a peak that is lower than a Mesokurtic distribution. Their names are derived from prefix platy, meaning broad. All uniform distributions are Platykurtic. Also, the discrete probability distribution from a single flip of a coin is Platykurtic. The following summary table helps to identify or to know what the best measure of central tendency with respect to the different types of the variable. Now, this suitability is based on the variable types. If the variable is nominal, the best measure is the mode. If the variable is ordinal, it is the median. If the variable is interval or the ratio which is not skewed, the best measure is the mean. In case the interval or the ratio scale is skewed, the best measure to use is the median. Now friends, it's time to summarize the module. The common quantities which are used to outline the data set is the center or the mean value. The center is defined as a single value which should be chosen in such a manner that it gives a reasonable and fair view about the normality of the data values. There are many ways in which the data values can be statistically approximated. One of the most useful techniques of central tendency is the mean. However, using only the mean to approximate normality can lead to fallacious conclusions. The various measures of central tendency highlight the items which have the capacity of being together. Such kinds of measures of statistical averages helps in arriving at some central value and is one of the most representative figure from the entire set of values. There are many ways of approximating a data set. There are many measures which have been defined and explained in statistics, namely the mean, median, the mode, the mean deviation, the standard deviation, the range. And not only this, the measures of asymmetry, namely the kurtices, have been explained and described along with their relevant types so as to provide a clear picture of what actually these measures mean and how they are used as being a statistical measure. The different measures of central tendency or the statistical averages highlight the items which have a tendency to come together. Such a kind of measure of the central tendency is one of the most representative figures from the entire set of the data. It is also known as the statistical average. Under the measures of central tendency, the mean, the median and the mode are the most popular averages that are studied. In order to arrive at suitable answers, the statistical techniques called measures of dispersion are then applied. Skewness is a measure of symmetry. A distribution or data set is symmetric if it looks the same to the left and right of the center point. The present module has explained in detail the various measures of central tendency along with the measures of dispersion and asymmetry.